Hi, I'm Cesar Cordova, and today we'll be solving a problem that involves Gauss's law. We're given a small particle that's attached by a string to a conductive plate of infinite magnitude. And we know that that string has a 27.4 degree angle with the plate. We're also given the mass of this ball, and we're asked to obtain the charge density of that plate. First, we'll make a free force diagram for the sphere. We have the sphere, and we know that there is a force going this way, that's a tension. And due to the place where it's located, we know that there is a force going this way, that's the electric force, and the weight of the same sphere. Since the sphere is at rest, we know that the sum of all these forces is 0. Thus, the x component of the tension has to be equal to the force, and the y component of the tension has to be equal to the weight. In other words, we'll know that tension will be equal to, in the x component, Fe negative, and on the y component, minus W. And we also know that tension has a degree of 27 on this coordinate. So this has to be 90 minus 27, which is 62.6 degrees. So we get that the tangent of 62.6 degrees will be equal to the y component, which will be this one, in other words, weight, divided by the electric force. And from here we can get Fe, and we get that Fe will be equal to tangent of 62.6 divided by weight. Now, we also know that the charge of a particle in an electric field multiplied by that electric field will give us the force. So we also know that Q times E equals Fe. Thus, E, or the electric field generated by the whole surface, equals Fe in Q, which equals the tangent of 62.6 degrees divided by QW. Now that we know the value of the electric field, we will go and create our Gaussian surface. We have the plane here, and we want our surface to completely enclose this plane. So we'll create a surface that's in front of it and behind of it. And we know that the electric field multiplied by the area of our Gaussian surface will equal the enclosed charge, which will be the total charge of this, divided by epsilon 0. Now, we can see that this has an area, and this will have the exact same area, and this will have the exact same area. So we get that epsilon times 2a will equal, and our charge will be sigma times area, which is this area, divided by epsilon 0. We can see that a well, area is in both sides right here, so we just get rid of it. And we get that sigma will be will be equal to epsilon 0 times 2 times the electric field, which will equal, in turn, epsilon 2 times epsilon 0 times this. Tangent of 62.6 divided by Q and divided by W, which we will just replace with mass times gravity. And from here, we can obtain our values.